Welcome back. We're going to do example 4 both ways by elimination and substitution. But the first few steps remain the same. We're going to substitute our values for x and y into ax squared plus bx plus c equals y. My first point, 0, 5, I will have a times 0 squared plus b times 0 plus c equals 5 simplifies down to c equals 5. Love having that x coordinate as a 0. Simplifies the process a bit. Next, we're going to substitute 2, 3. So I'll have a times 2 squared plus b times 2 plus c equals 3. 4a plus 2b plus c equals 3. Next, we'll substitute in negative 1 for x and 0 for y. So I have a times negative 1 squared plus b times negative 1 plus c equals 0. A minus b plus c equals 0. Step 1, generate those three equations. 2, solve one of the equations for c. We're already done. We don't have to do that. Next, step 3 is substitute this, what we've solved for c, into both those equations. So my first equation becomes 4a plus 2b, substituting 5 in for c, and then simplifying, in this case subtracting 5 from both sides. We're left with 4a plus 2b equals negative 2. Doing the same thing on the next equation, a minus b plus 5 equals 0. Subtracting 5 from both sides, a minus b equals negative 5. Up to this point, everything is the same with elimination and substitution. Let's try to do substitutions. I'm going to draw a line across there because those steps don't change. Now in substitution, you're going to solve one or the other of these two equations for a or b. It doesn't matter what you do. I tend to avoid fractions if I can. So I'm looking for a variable that has a coefficient of 1 that's going to be easy to solve for. And if I use this equation, this a minus b equals negative 5, and I add b to both sides, I'm left with a equals b minus 5. Now, I take this expression, b minus 5, and I'm going to substitute it in for a into that other equation from step 3. So I have 4 times b minus 5, substituting that in for a, plus 2b equals negative 2. Use the distributive property for b minus 20 plus 2b equals negative 2. Combine my like terms. Add 20 to both sides. 6b equals 18, and divide by 6. b equals 3. So far, I have c equals 5 and b equals negative, how about positive 3? Now I use this one last time, one last substitution, and pop it in this other equation. So I have a equals 3 minus 5, a equals negative 2. So I have all values for my a, b, and c. So my general equation for the parabola that contains 0, 5, 2, 3, negative 1, 0 is negative 2x squared plus 3x plus 5 equals y. I'm going to erase from my line down, and then we're going to do elimination one more time and show you that each way we're going to end up with negative 2x squared plus 3x plus 5 equals y. Remembering when I do elimination, I like to line up my two equations. 4b, helps if I copy it down right. Let me grab that eraser. Pick a little eraser this time. One more time, but this time with the correct variables. I have 4a plus 2b equals negative 2. And then a minus b equals negative 5. Once again, I want to look at my a's or my b's and see if one is easier to eliminate than the other. Seems to me that if I multiply the bottom equation by 2, my b's will drop out. So my top equation, nothing has changed, so I have 4a plus 2b equals negative 2. Using the distributive property here to distribute that positive 2 through the second equation, I have 2a minus 2b equals negative 10. Adding my equations together, 4 plus 2, I'm left with 6a. Positive 2b minus 2b eliminate each other, so that equals negative 12. Divide both sides by 6. A equals negative 2. Taking this answer and substituting it into either one of these equations from step 3, I'll just use this one. Negative 2 minus b equals negative 5. Add positive 2 to both sides. B equals negative 3. Divide by negative 1. B is 3. So the general equation, once again, is negative 2x squared plus 3x plus 5 equals y. I'd like you to pause the video at this point and go ahead and try example 5 on your own. Use either elimination or substitution, whichever one you think you feel more comfortable using. Start up the video when you're finished and check your answer. Let's see how you did. Now remember, it doesn't matter if you use elimination or substitution, the first 3 steps are going to remain the same. So we're going to use our standard form and substitute in our values, our coordinating points, x and y, in for x and y. So my first point, I have 0, negative 2, so that's a times 0 squared plus b times 0 plus c equals negative 2. C equals negative 2. Next, we're going to substitute 1 in, so that's a times 1 squared plus b times 1 plus c equals 1. So I have a plus b plus c equals 1. And lastly, I put in negative 1, negative 7. That's a negative 1 squared plus b times negative 1 plus c equals negative 7. A minus b plus c equals negative 7. Step 1, substitute in those ordered pairs, x and y, into ax squared plus bx plus c equals y. Now I solve one of them for c. Fortunately for us, that's already done. C is negative 2. So I take this and I'm going to substitute it in to those other equations. Doing so, I have a plus b minus 2 equals 1. A plus b equals 3. Continuing on, I have a minus b minus 2 equals negative 7. A minus b equals negative 5. Now here you had to make a choice. Do you want to do substitution or elimination? Well, in this case, I don't think it matters. We might do both ways, just so you can see it. A plus B equals 3, and A minus B equals negative 5. Add them up, 2A equals negative 2, A equals negative 1. My B's eliminated really very easily. If I pick either one of these equations and substitute negative 1, I'll have negative 1 plus B equals 3, B equals 4. So the general equation, and this was using elimination, negative x squared plus 4x minus 2 equals y as the general equation. Now that was elimination. I'm going to draw a line down my board.